This is Akhilesh Son from Saraswati Balika Vidya Mandir Inter College, Pithoragarh. Today I am here for explaining some theorem, Gauss's theorem and its application. In the previous lecture, we studied about some fundamental things which are required for proving Gauss's theorem. Those were, first of them was area vector, small area element, and electric flux. We have already told you about the definition of these fundamental or essential things which are required for Gauss's theorem. Before I start Gauss's theorem to prove, I would like to explain some concept that is very important. First one topic, that is solid angle. Solid angle, look at this figure. This I have just constructed here a sphere. This is the new word for the students in 12th level which are just entering at this time, because oftenly we have heard about the plane angle. If I am talking about whatever I am just saying here, please listen carefully. I am just explaining at first plane angle. Plane angle I am just describing, though most students well known about this word plane angle. Plane angle means, if I am just talking about the circle, the arc of the circle, any arc of the circle, and the distance of that circle from the center of and the distance of that arc from the center of circle is equivalent to the radius of that circle, then those arcs of the circle which subtends the angle at the center of that circle, that is known as the plane angle. In case of circle, the arc of the circle which subtends the angle at the center, that is known as the plane angle. Now we are talking about the solid angle. Solid angle means, now we are taking the case of sphere. In that case of circle, that was plane angle, but in case of that, the angle subtended by any portion or any surface of the sphere at the center of the sphere, that is known as the solid angle. Again I am repeating, the angle subtended by which angle, that is subtended by the surface of any sphere at the center of that sphere, that is known as solid angle, and it is denoted by omega. Omega is the solid angle subtended by the whole surface of the sphere at the center. How we can calculate the formula of this solid angle? I am just taking the example of this geometry. In this sphere, this is the whole sphere of radius small r. I have taken a small element, area element, that is dA. Then dA small area element is subtending an angle at the center O, that is known as the solid angle subtended by this small area element at the center of sphere O, that is denoted by d omega. And in case of sphere, always dA, that is the area, is directly proportional to the square of radius. This is the mathematical law that the surface area of any sphere is directly proportional to the square of its radius. Then the ratio of area and the square of the radius is always constant, and this constant ratio is called the solid angle. We can denote d omega equals to dA by r square. Now the question arises, how can I say that this ratio is a constant after placing the formula of area? In case 4 pi r square cancel out. If I am taking the whole case of the whole area, the area of the whole sphere, in that case dA, on behalf of dA, that will be 4 pi r square. So I have taken this here, that the ratio of dA upon r square, that is known as a constant. So this is known as d omega. In case of the whole area, that is known as by omega, and the unit of omega is always steradian. So this is a particular definition of solid angle. Whole and soul, the conclusion is the conclusion way. The definition of solid angle is that the angle subtended by the surface of sphere, you can say any surface, small area surface or the whole surface area, by the whole surface or the any small area surface at the center of sphere, that is known as solid angle. That is most important fact for Gauss's theorem. Now in case of second thing, I am taking the second one thing. What will happen if we are saying that suppose this is a point O at a distance R, any point P, small area vector dA, that is, and area vector dA, that is the vector dA, and this is the intensity vector E, angle theta. Now I am again, if I am just drawing a sphere here, it has given that this dA is a small area element at the distance R from point O, and if you are just drawing in another sphere of the same distance OP, that is equal to R, by assuming this is a center, then the projection of this small area on that sphere, that will be dA cos of theta. In that case, what will happen? The value of d omega, that will d omega equals to dA cos of theta upon R square. That is important formula for Gauss's theorem. I am again repeating this statement that if we are drawing a sphere equivalent to this distance R and the center O is assumed as the center of this sphere also, in that case the projection of this small area dA on the surface of this sphere will be denoted by dA cos theta. In that case, d omega equals to dA cos theta upon R square, and this is the important formula. When we will derive or prove Gauss's theorem, we will replace on behalf of this formula dA cos theta upon R square equal to d omega.